Welcome to Daily Papers, the podcast where we break down the latest and most interesting research papers into something you can digest on your morning commute.
Today, we're diving into the world of artificial intelligence, but with a bit of a spy movie twist. We're talking about secret codes, sneaky prompts, and a cat-and-mouse game between AI developers and those trying to break their systems.
Exactly. We've all probably used large language models, or LLMs. That's the tech behind tools like ChatGPT. You ask it a question, it gives you an answer. But these AIs have rules. They have safety guardrails to stop them from generating harmful or dangerous content.
You can't just ask it, "How do I build a bomb?" and expect to get a recipe. It'll politely refuse, saying it can't help with that. These safety features are like the AI's conscience. But what if you could trick it into ignoring that conscience?
That's called a jailbreak, and it's a huge area of research. And the paper we're looking at today introduces a particularly clever way to do it. It's called MetaCipher, a general and extensible reinforcement learning framework for obfuscation-based jailbreak attacks on black box LLMs.
That is a mouthful. Let's break it down. What exactly is an obfuscation-based jailbreak?
So, obfuscation just means making something intentionally confusing or unclear. In this context, it means hiding your malicious request in plain sight. Most safety guardrails work by looking for specific keywords like bomb, hack, or steal.
So the guardrail is like a bouncer at a club with a list of troublemakers. If your name is on the list, you're not getting in.
Perfect analogy. An obfuscation attack is like writing your name in a secret code. The bouncer looks at it, doesn't see a name on their list, and lets you in. But the main AI, which is much smarter than the bouncer, can still decode your message and understand what you really want.
So you're tricking the simple safety filter, but leveraging the powerful reasoning of the main AI. So how does this MetaCipher system actually do that?
It's a fascinating multi-step process that basically runs on autopilot. First, you give it a malicious prompt, like write a script to steal credit card information. MetaCipher has a component that acts like a detective, identifying the malicious keywords, in this case, steal and credit card.
Okay, it's identified the words that would normally get it blocked. Now what?
This is where the cipher part of MetaCipher comes in. It has a whole toolbox, a cipher pool, with 21 different types of secret codes. These can be anything from simple reversal ciphers, where hello becomes hola, to leet-speak, where you replace letters with numbers, or even more complex substitution ciphers.
A whole library of secret codes. So it picks one?
It picks one and then it encrypts only the malicious keywords. The rest of the prompt stays normal. It then sends this coded message to the target AI, like a GPT-4 or a Claude model. The prompt might look something like, write a script to mask 1, mask 2 information. And then it provides the encrypted versions of steal and credit card, and even a little hint on how to decode them.
That is clever, but with 21 ciphers, how does it know which one will work? Is it just guessing?
This is the most brilliant part of the whole system. It doesn't guess, it learns. This is where the reinforcement learning part of the title comes into play. Think of it like training a dog.
Okay, I'm with you.
MetaCipher tries a cipher. It then looks at the AI's response. Another AI, acting as a judge, grades the outcome. Did the jailbreak work? Great, that's a success. Positive reward. Did the AI refuse to answer? That's a rejection. No reward. Or did the AI get confused and spit out nonsense? That's a wrong decryption, and it gets a negative reward.
So it's trial and error. If a cipher works, it gets a virtual treat and is more likely to be used again for that type of request and against that specific AI. If it fails, it learns not to use that one and tries something else from its toolbox.
Precisely. It adapts. It learns the specific weaknesses of each different LLM it's attacking. A cipher that works wonders against one model might fail spectacularly against another. MetaCipher figures this out on its own over a few attempts.
And what were the results? Did this spycraft actually work?
It worked astonishingly well. The paper reports that MetaCipher achieved over a 92% attack success rate on most standard LLMs, and even against the most advanced reasoning-capable models, the ones that are supposed to be harder to trick, it still succeeded over 74% of the time.
Wow, a 74% success rate against the toughest models is a huge deal. That shows this method is really effective.
It really is. They even showed that the same framework could be adapted to jailbreak text-to-image models, getting them to generate harmful or restricted images.
So this all sounds a bit scary. Why are researchers building a better way to jailbreak AI?
It's a great question, and it gets to the heart of cybersecurity research. This isn't about creating tools for bad actors. It's about ethical hacking, or red teaming. You have to think like an attacker to build a better defense.
So by showing that these models can be tricked by coded language, they're highlighting a major vulnerability that AI companies need to fix.
Exactly. The old method of just filtering keywords is clearly not enough. The next generation of AI safety systems needs to be as smart as the AI itself, capable of understanding context and intent, even when it's hidden in a cipher.
So MetaCipher is less of a weapon and more of a stress test to help build stronger, safer AI for everyone. It's a roadmap showing developers where the walls need to be built higher.
That's the idea. It's a fascinating look into the ongoing arms race in AI safety, showing that the fight to keep these powerful tools aligned with human values is getting more sophisticated every day.
And that's all the time we have for today. Thanks for tuning in to Daily Papers.